Hi, I'm Wadi Shingeti. I will talk about the Identity and Access Management (IAM) and Multi-Factor Authentications (MFA). My teammates are Wajd. She will discuss securing financial data using cloud databases on AWS. Yushai, who will cover network protection and security policies. Baida, she will explain advanced security techniques offered by AWS for financial institutions. Now, in this presentation, we will focus on the important parts of security in financial services, especially in cloud systems. As you know, security is very important in the financial sector because of the sensitive client data, transaction logs, and rules that must be followed. We will talk about how Amazon Web Services (AWS) helps solve these challenges by giving a secure and flexible system for financial institutions. AWS gives different tools and services to improve security, making sure that systems meet both functional and rule requirements. We will also talk about the company rules that are important for cloud security. These rules include authorization policies, which control who can access what is in the company. These rules help make sure security is applied to all users and resources. We will also explain identity and access management (IAM), which is a key part of AWS security. This will include how user groups are organized to manage access based on their rules, making sure everyone gets only the access they need. In the financial sector, security is critical due to several key factors. One, data sensitivity. Financial institutions handle highly sensitive data such as account details and transaction histories. Any breach of these data could result in significant financial and reputational damage. Two, compliance with strict regulations. Financial institutions are required to follow strict regulation to protect data and prevent fraud. Three, necessary security measures to protect data from unauthorized access and prevent cyber attacks. For AWS Cloud Solutions, which offer flexible and strong security tools such as identity and access management, IAM, network segmentation, and ensuring the protection of financial data and compliance with regulations. Now, this chart explains how identity and access management (IAM) works in AWS using authorizational policies to manage permissions and users securely. IAM policy define what users or groups can access within AWS. IAM group, a group of users sharing the same policies for easier permission management. IAM user is an individual inheriting permissions from their group or specific policies. AWS services like EC2 and S3, access to these services is controlled by policies. Organizational policies enable centralized permission management, ensuring security and compliance.
Hello, my name is Wajd, and today I'm going to introduce our storage services. In my part, I did implement 4 services. The first service is Amazon S3, which is stores a large amount of data like files, backups. It's good for storing files you don't need to access often. It's also safe and scalable for different kind of data. The second one is Amazon S3 Glacier. It's usually used for storing data in long term like archives. Perfect for all data that you need to keep safe but don't need to use regularly. And it's also very cheap and meets legal requirements for data storage. The third one is DynamoDB. It's fast and flexible, and it's also manage a large amount of data and adjust to your needs. It's automatically handle big changes in data size. Finally, Amazon RDS, MySQL. It's managed SQL database service. Automates things like backup and update, saves time and effort by managing the database for you. So after I did introduce our services, let me move on to the design implementation. So the first service we are going to implement is Amazon S3 service. After we access this page, we're gonna create a bucket. We're gonna give it a name. Then we're gonna enable ACLs. So the bucket can be accessed by other AWS account. After that, we're gonna uncheck or block all public access to make the bucket public. After this, we're gonna enable bucket versioning. So we can receive restrictive restore every version of the bucket we create. And you can also enable a tag for this specific bucket, so it can keep everything organized. And we press create bucket, and now it will be created successfully. Okay, so moving on to RDS in MySQL. So after accessing the page, we are going to create a database. We are going to pick MySQL, then pick the free trail, because we are just testing the environment. Then we will keep the database identifier as a default. And we will tick the auto-generate password option checked. And finally, we're gonna create our database. Moving on to DynamoDB, I will create a table and name it. We will make the partition key as a number. And we will sort the key as a string. The table setting, we will make it as a customized, so it can modify and make it meet our project specification. And keep the table class as a standard. And finally, we will create the table. Moving on to Amazon S3 Glacier, we are going to create a vault and give it a name. And simply just create it. This concludes my part, and now I'm going to over to Baida. Thank you.
Hello, this is Baida Sabawi, and today I will be presenting key security services provided by Amazon Web Server AWS, which are critical for maintaining secure cloud environments, particularly in industries such as banking, insurance, and trading. AWS offers a comprehensive set of security tools designed to protect sensitive data, monitor infrastructure real-time, detect threats, and mitigate risk. My presentation will focus on 5 core services that ensure the security and integrity of cloud applications. I will start with the AWS CloudTrail, used for editing and monitoring all API activity within our AWS account. AWS CloudWatch, used for real-time performance monitoring and alerting. AWS GuardDuty, used for threat detection services that continuously monitors for malicious or unauthorized behavior. The most important thing is AWS Web Application Firewall, WAF, which protects our web applications from common exploits like SQL injection and cross-site scripting. The last thing is AWS Shield, used to manage distributed denial of service protection that safeguards our applications from these attacks. Let's begin by diving into how each of these services works and how they can be effectively used to secure AWS environments. I will start with the AWS CloudTrail. We can create a new trail by pressing here. We can give it any name, like I will give it name test, and create a trail. As we see here, our trail is being created successfully. Let me move to AWS CloudWatch. In AWS CloudWatch, we can use alarm to make an alarm to monitor our utilization, like CPU. Let me make a monitor to make alarm, sorry, to monitor CPU utilization in EC2 instances. I will choose EC2, CTP, this one, CPU utilization. Okay, press, then select metric. I will make the threshold up to 80%. And next. This one should be enabled in alarm and select existing SNS topic. Send notification to, let me choose SNS. And next. The alarm name, let me give it name CPU. And next. Now leave everything as default and create alarm. Let me check if our alarm being created. That's our alarm, CPU alarm, being created successfully. Now let me move back to the other part is GuardDuty. When GuardDuty need to be enabled, we can click on Get Start if GuardDuty is not already enabled. For us, here is already enabled. The other thing is GuardDuty automatically being monitoring across the AWS environment once activated. In AWS GuardDuty, we can monitor different AWS resources for security threats, like as we see here in the left pane, like findings. We can view, analyze, and detect threats. In EC2 malware scan, we can scan EC2 instance for malware. S3 protections, we can monitor S3 bucket for unauthorized access or malicious activity. EKS protections, secure Amazon EKS cluster from any threats. Runtime monitoring, detect issue real-time. Malware protection for EC2 and S3. Detect malware in EC2 instance and S3 buckets. RDS protection, protect relational database RDS, and Lambda protection, secure AWS Lambda functions from threats. This helps us to secure various AWS resources effectively. And let me just scroll down to the findings. If any threats findings, gonna be like low, medium, and high. Specific as, okay. Let we move back to WAF. We can create web ACL. This one need to be keep it active, regional resources, and give it a name. Let me choose the same name for all of them, tests, and keep everything as default. And next, and next. Create web ACL. Because we use the free version, this one it's not running successfully, but I demonstrate all the steps we need to do it to create web ACL. The last part is AWS Shield. Although AWS Shield Advanced isn't available for hands-on practice, here's how we would approach using a protect our resources from distributed denial of service attacks. I will give an overview of AWS Shield Advanced. We can verify Shield standards. We will start by checking that AWS Shield standard is active and monitoring our resources, providing basic protection against distributed denial of service attack. Enable Shield Advanced. This one is optional. If we required stronger protection, we can enable AWS Shield Advanced for enhanced diagnostic, advanced distributed denial of service, and cost mitigation in case of attacks. Integrate with the CloudWatch. We will integrate Shield with the CloudWatch, allowing us to monitor distributed denial of service related metrics and configure alert that notify us if something exceeds our predefined thresholds. The last thing is review attack reports. Finally, we will walk through how we can access and interpret distributed denial of service attack reports in the Shield console, which help us understand the nature of any threats and improve our defense strategies. By following these steps, we ensure that our AWS resources are thoroughly protected from distributed denial of service attack, keeping our system secure and safe. Thank you.
Hi everyone, my name is Yosiano Hartanto, and I will present about the AWS network protection. Okay, let's see. This is several network services that we can see in the diagram. They have a VPC or virtual private cloud. It's on the green box here. Basically, it's the container of all the AWS resources we have. And then the blue dotted line here, it's a availability zone. Basically, if we want to have high availability, so we need to put into several availability zones. And the next one is subnet. Subnet here, I put on 4 boxes. Basically, it's on each availability zone, we need to set up the subnet. Subnet, basically, it's smaller networks of the virtual network. It's containing several surfaces inside, and all the resources we can divide based on the public or private, means who can access that one. And they have several security inside, which is the security groups, route tables, network ACL, net gateway, and so on. And both of the availability zone, we do replication of them. Okay, so we continue to see in the AWS. The first one, we need to create the VPC. How to create the VPC? We just open the AWS and then we search VPC. Okay, this is all. And then we create the VPC here and choose the VPC only. The name of the VPC is like the main VPC. And then we input the IPv4 CIDR 10.0.0.0/16. Okay, and then just create the VPC here. And this is the VPC we already have. And then we need to create the subnet. As seen in the diagram, we create 2 subnet, the public one and then the private one. Okay, we create now the public. Before creating the subnet, we need to choose the VPC that we just created, and then we input the public subnet, first one, and then the availability zone. Make sure it's on the same availability zone as before, and then this one 10.0.0.010/24. Okay, and then create subnet. We just wait for the public one and then create another one in the same VPC. Just name the private. And don't forget to choose the same availability zone. In this case, we will create 2, for example, 10.0.20/24. Let's create the subnet. After creating the subnet, we need to set up. Okay, we need to set up the security groups. This is as seen, public and private subnet. We search the security group here. This is for the VPC features. Yeah, we can see here in the security group, we can create security group to control inbound and outbound traffic. Basically, it's by default, it's denying all the traffic. And this is we can put the name web server security server group, and then choose the VPC we created. And if we want to add some rules, inbound or outbound rules, basically like we want to deny the ping or whatever, we can put here like this one, and then create security group. This is we need to add the description, web server group. Just create a security group here. Okay, and after the security group, we need to create the route tables. Route tables we can see here on the left side, left menu here. This is the route table. Route table, we can click on the create route table. Yeah, this is based on the zone. Let's see zone 1, public. Okay, we choose the VPC, create route table, and then this one, yeah, we can edit routes. And then if we want to have some of the settings here, we can choose here. After the route tables, we set up all the route tables. We set up the net gateway. Net gateway is a VPC also. This is the net gateway. Basically, it's forwarding the traffic from private subnet to service outside the VPC. In example, internet. And the external service cannot initiate connection into the subnet. This is the network address translation. Yeah, this is we can choose means like if you want our private to connect to the internet, we choose here. And then we need to allocate the elastic IP, and then we just need to create the net gateway. Yeah, and the last one is the network access control list. Network access control list. We can search here. Network ACL. Basically, network ACL is the virtual firewall at the subnet level. Yeah, this is we have two network ACL. We can check based on the VPC, and then this is the first one. This is the network ACL. Yeah, we can edit rows here. Okay, this is all from me. Thank you.
Now here's the AWS Identity and Access Management System, which is divided into two main components. First, the identities, which include users. Those are individual granted permissions to access AWS resources. Groups, which are collections of users who share the same permissions. Rules that are used to assign specific permissions for tasks or services within the system. And finally, credentials, such as passwords or access keys used to identify users. The second component is permissions, which refers to what identities are allowed to access, and it include policies, a set of rules that define the permissions granted to identities. Statements, which are specific details outlining what each identity is permitted to do. So the system ensures that each identity, like a user, group, or rule, has only the necessary permissions to perform their tasks, and protecting system from unauthorized access or misuse of resources. Now this explain the different user groups and their permissions in the system, divided into 5 main rules. The root user, which has full access to AWS resources and services. Administrator, responsible for the day-to-day administrative tasks like managing users and configuring services. Manager has limited access to resources related to their specific department. Support has restricted access to AWS services for maintenance and troubleshooting purposes. Client have restricted access to specific data and reports as defined. Now, this explain how permissions are divided based on the role of each group to ensure security and efficiency in using the system. The strong password policy enhances security by reducing the risk of unauthorized access due to weak passwords. In AWS, password rules are enforced through IAM. Password policy required at least 8 characters, a mix of uppercase, lowercase numbers, and one special character. Passwords explain every 180 days, and reuse of old password is prevented in reduced breach risks. MFA requires users to provide 2 different factors to verify their identity before accessing accounts. Typically, this includes something in the user knows, like a password, and something they have, such as a code sent to their phone or an MFA device. MFA act as an additional layer of protection, even if the password is compromised. The attacker would still need the second factor to access the account. This method is particularly important for sensitive accounts like root or administrator accounts, as it provides extra protection against attacks. A virtual MFA device was selected to secure the user's account. After that, the user clicks next step to continue the setup. The virtual device uses an app like Google Authenticator to generate additional security codes for safe login. Steps to set up a virtual MF is: 1, we should open the MFA app and select create a new account, and then we scan the generated QR code using the app. Then we choose show secret key for manual setup, then enter the key in the app. This links the account to the MFA app, enhancing the security. Finally, in the authentication code, one box, type the one-time password that currently appears in the virtual MFA device. Wait up to 30 seconds for the device to generate a new one-time password. Then type the second one-time password in the authentication code too. Then we choose to activate the virtual MFA. In conclusion, we can say that robust security measures are essential for protecting sensitive financial data. AWS framework can provide scalable and compliant solutions tailored for financial services. Thank you.